L'Hopital's rule. Suppose that f and g are differentiable function at x equals c, and limit of fx and limit of gx when x approaches c equals 0, or that both limits of f and g when x approaches c equal to plus minus infinity, then the limit of f over g when x approaches infinity equals to the limit of the derivative of x over the derivative of g when x approaches c. Please pay attention. The limit of both function f and g has to be or 0, or that both limits can be any combination of infinity plus minus. L'Hopital rule can be written in short like this. The limit of f over g when x approaches c, if it is 0 over 0 or plus minus infinity over plus minus infinity, only then this limit equal to the limit of the derivative of f over the derivative of g when x approaches c. Let's see some examples. I guess that you remember this. The limit of sine x over x when x approaches 0, if you remember, supposed to be 1. But now we have a better way to do that, just the easy way. We know that sine of 0 is 0, and obviously x at 0 is 0, and because of that, the form here is 0 over 0, so I can go ahead and use L'Hopital rule. This is this case. So I'm replacing this limit by the limit of x approaches 0 of the derivative of sine x over the derivative of x. I get limit of cosine x over 1 when x approaches 0. At any step after applying L'Hopital, you should try to substitute the limit in, because you may lucky and you may get already the answer. For example, in this step, you can go ahead and replace x by 0. Cosine 0 over 1 is just 1. You probably also remember these guys. This was not very easy using other techniques than L'Hopital. So here's L'Hopital rule here. You substitute 0 and you get a tangent 5x is 0 and also tangent 7x is 0. Pay attention. Yes, if tangent 0 is 0, then obviously the limit of tangent 5x when x approaches 0 is 0. And the same with tangent of 7x. The form here is again the form of 0 over 0. So I can use L'Hopital. I'm replacing this limit by the limit x approaches 0 of the derivative of tangent 5x over the derivative of tangent 7x. Don't forget the chain rule. Now I'm trying to substitute 0 for the x. And it is working. I would like to recall that secant of 0 is 1. And I get 5 over 7. Example. Let's find the limit of this rational function when x approaches 2. As usual, we try to substitute, and look what we get. We get 0 over 0. 0 over 0 was always good news. But now it's even better news, because I can use L'Hopital. I get the limit when x approaches 2 of the derivative of the polynomial in the numerator over the derivative of the polynomial in the denominator. I get the limit of 2x minus 1 over 2x minus 3 when x approaches 2. As usual, we are trying now to substitute 2. And we get 3 over 1, which equals 3. So this is the solution. Example. The limit now of this rational function when x approaches to negative infinity. We see that the form here is negative infinity over infinity. It is negative infinity on top because you have x cubed, and it's infinity because you have x to the power of 2. Please note that L'Hopital works in this case as well, which means it doesn't have to be infinity over infinity or minus infinity over minus infinity. It is infinity plus or minus over infinity plus or minus. I can use L'Hopital. So we're going to differentiate the top and the bottom, and we get this. Now we try again to see if this is any better. And we find out that this is now infinity over minus infinity. Infinity on top because we have x to the power of 2, and negative infinity on the bottom because we have 2 times x. But we can apply L'Hopital as many times as we like if we have the right conditions, and we do. So we apply again, and we get the limit of 18x over 2 when x approaches negative infinity. This is the limit of 9 times x when x approaches negative infinity, and we get negative infinity. I would like to recall that we also could divide top and bottom by x to the power of 2. Another example. Limit of 3e to the power of 3x plus 5 over 2e to the power of 3x plus 7 when x approaches infinity. By the way, we know how to do it in a different way, but now I would like to use L'Hopital because it's actually much easier. At infinity, obviously, we get the form of infinity over infinity, so go ahead and use L'Hopital. And we get limit of x approaches to infinity of 9e to the power of 3x over 6e to the power of 3x. Don't forget to use the chain rule when you differentiate. This is again infinity over infinity, but I can keep and do it forever. E to the 3x will stay e to the 3x when I'm differentiating. So the rule number 1 of L'Hopital is you always try to simplify before you apply L'Hopital. And if we simplify here, we don't need to use L'Hopital anymore because we get the limit of 9 over 6 when x approaches infinity, but this limit is 9 over 6, which also is 3 over 2. In all the examples we did, the use of L'Hopital rule was optional. Sometimes L'Hopital's rule is not optional. For example, look at this limit. Of course, you can explain why we are going to get what we will, but explanations are not good enough mathematically. You have to show mathematically using theorems and rules that this limit is whatever it is. Let's see, even though we can guess already. The limit of x over e to the x when x approaches to infinity has the form of infinity over infinity, because limit of x when x approaches infinity is infinity, and so is the limit of e to the x when x approaches infinity. This is definitely this form, so I'm going now to do this, and I get the limit of 1 over e to the x when x approaches infinity. This is clearly 0, because it's 1 over huge. We could guess easily this limit because e to the x is dominating the ratio of x over e to the x and pulls everything to 0. But again, we have to show mathematically that the limit is 0. Example. The limit of ln of x over x when x approaches infinity. Here we have again the form of infinity over infinity because the limit of ln at infinity is infinity, and obviously the limit of x when x approaches infinity equals infinity. We are going to use L'Hopital. And we get limit of 1 over x over 1 of x approaching infinity, which is just the limit of 1 over x when x approaches infinity, and we get 0. All the L'Hopital forms that we did today were very easy forms. In the next section, we are going to do more complicated ones.